So, good morning, everyone. Please take your seats. So let me welcome you on behalf of Hirecord. This is a green meeting, the first seminar meeting of Hirecord, a project, an EU project on new technologies based on rotating packed beds for CO2 capture. Before starting the meeting, or the seminar, I would like to mention that the Faculty of Chemistry will take pictures for social media and for our website. If someone is not fine with that, please raise your hand and say that I don't want to be on this picture. So, with no further delay, I want to welcome Dr. Sakis Papadopoulos, who is the coordinator also of this project. And he will start with some opening remarks about what this project is about, and what you should expect in the meeting today.
Okay. Good morning, everyone. Thank you for attending our workshop. Thank you, Stavro, for hosting it, for the excellent organization, and Nada, of course, who did all the work. So yeah, we're from the Hirecord project. I'm from the Center for Research and Technology Hellas. We're a research center in Thessaloniki, Greece. I'm assuming that the audience here will be aware of CCUS in general and why it's important. Emissions, greenhouse gas emissions are we need to mitigate the effects, their negative effects on the environment. So Hirecord is doing just that. The title of the project is Scaling Up of a Rotating Packed Bed with an Advanced Solvent for Post-Combustion CO2 Capture. We have participants from several countries of Europe, several British partners here, from France, Germany, Austria, of course, and Greece. So we're working on solvent-based CO2 capture. So conventionally, what happens is when you have a flue gas and you want to remove the CO2, you typically have absorption and desorption columns. So the flue gas comes from the bottom, a solvent stream comes from the top, and then they react, and then you put the product of the reaction into a desorption column where you put heat at around 120 degrees Celsius, and then the CO2 is released and the solvent is regenerated. The solvent types are amine molecules, typically. So this is, in general, a well-established technology, absorption, desorption, something that's very well known in the industry, in packed bed columns. The problem is that they have a high capital costs and high operating costs, especially due to the regeneration energy that is needed here. The solvent that is a reference solvent for this kind of research is monoethanolamine, this molecule here. It is quite reactive, it captures CO2, but it has a lot of disadvantages. So, we need new solvents and improved processes. So there are different types of approaches in terms of intensifying the systems and reducing the costs. One approach is to use the standard absorption desorption technology, where you actually do some heat integration internally in order to reduce the energy here or improve the kinetics of the reaction. Another approach is with phase change solvents. This is a type of solvents that again operate typically in absorption desorption columns, and they separate into two liquid phases after they absorb CO2 or after the temperature is increased. So the advantage here is that you get to regenerate, to recycle part of the upper layer of the solvent, which is poor in CO2, back to the absorber, whereas the rich in CO2 part, you put it in the desorber and you reduce the flow, and you get benefits in terms of economics. What we do here is something different. It's called a rotating packed bed. It's a highly intensified piece of equipment. You see some pictures here from the projects that led to Hirecord, the previous work from some partners. So rotating packed beds generate an intense centrifugal field as they spin, which significantly enhances the mass transfer and greatly facilitates CO2 absorption. You see here some tests that have been done by Newcastle, Carbon Clean, and possibly Richard Allen too, yeah, who are partners in Hirecord. In Glasgow, you see an RPB absorber here, and you see an equivalent RPB packed bed absorber here. So you see the footprint is the difference in footprint is enormous, yeah. So we're talking about something like 10 to 15 times lower volume, maybe even more than packed bed columns. Capital costs obviously decrease a lot. They have very short liquid residence times, so this is good for the equipment, and they also enable reduction of up to 20% of the total energy consumption, especially with the technology that we are developing here in Hirecord, which is an intensified RPB desorber, and I'm sure you will hear about that. So this is what Hirecord is about. We're actually building a 10-ton per day capture plant with rotating packed beds for the first time in the world. It comprises of a dual RPB absorber, so you have some benefits out of that. You get to cool down a little bit the stream and the kinetics improve. You see the pilot plant here. These are the absorbers. They're in development. We're going to have the pilot plant completed very soon, and we're going to demonstrate it in three sites. We're using a commercial solvent called APBS CDR Max. It's being commercialized by Carbon Clean. And of course, this is complemented with a lot of research work. So we're doing some tests of the solvent performance under real flue gases, which typically may contain contaminants like SOx or NOx, oxides that typically reduce the performance of the solvent. We're doing some work on thermodynamic modeling using an advanced equation of state called SAFT. The rotating packed bed desorber that we're using is called the RPB desorber with integrated stripper and boiler. So unlike what happens in packed beds where you have a separate reboiler, here the reboiler spins together with the desorber. So it's a spinning reboiler. So it improves heat transfer a lot. There is work on scaling up of the unit, as you see here, and of course we're going to have some studies on what to do with CO2 afterwards. So we're going to investigate ways of using rotating packed beds in order to produce some useful products out of CO2. And also we're going to see what happens if we move the CO2 to sequestration sites. We're going to have sustainability assessment studies and society and regulatory analysis. So this is basically all this. You are going to hear more details today from the expert speakers that we have. So this is it. Thank you very much and enjoy the workshop.